Topic 24 is a calculus of parametric equations. So we're looking at parametric calculus. And we did this as a ticket problem, but it's actually a really good problem for like the first sig test we're going to be doing. So a particle has velocity of v of t, which is negative 3t plus 6, and t squared minus 4. So this part right here, this is how the particle is moving in the x direction. It's its velocity in the x direction. So this basically is the same thing as dx dt. This part right here is the same as dy dt, or y prime. Okay, so right here, I'm going to know when is the particle at t equals 0. Well, if we start with velocity and we want to find position, then you have to go over and do an antiderivative. So the antiderivative is going to be negative 3/2 t squared plus 6t plus a constant. You can't forget the constant. We're told that at t equals 4, we're at 4 negative 3. So we're going to use this information to be able to figure out what c is. If I plug in 4, I get 3/2 times 4 squared. So that's going to be 8 times negative 3 is negative 24 plus c is equal to 0. So I'm going to get c equals 4. So that gives me my equation. I want to know the particle's position at t equals 0. Plugging in 0, its x position at that time is 4. Now, since this is a calculator test, there's another option for using this problem, and that is using the fundamental theorem of calculus. If I integrate t squared minus 4 on the interval from 0 to 4, I'm going to get the position at 4 for y minus the position of y at 0. Well, just punch that in your calculator. You get 5.333. Again, we were told that y of 4 equaled negative 3. So I can add 3 to the other side. I get 8.33 and then change signs. You get y is equal to negative 8.333. Now make sure you do answer the question. So at t equals 0, my position is 4 comma negative 8.333. Next one says, when is the particle's speed at t equals 0? Well, at t equals 0, we want to find out what the velocity is at that point. Well, the velocity at t equals 0 is going to be a vector. It's 6 negative 4, just plugging in 0. Speed is the magnitude of the velocity vector. So we just got to find the magnitude, which is the square root of 6 squared plus negative 4 squared. That gives me 52, square root of 52. Then I ask, is there any time when the particle is not moving? Well, the particle is not moving only when the velocity is equal to 0, 0. So the easiest thing to do is first find out when x is equal to 0. So the x component equals 0 when t equals 2. Now, if the y component also equals 0, then the particle is stationary. So I have t squared minus 4 is equal to 0. I want to see if this is true, so I plug in 2, and that is true. So the particle is not moving at t equals 0. Other kinds of questions. I could ask about the slope. The slope at any point is going to equal t squared minus 4 over negative 3t plus 6. Well, what if they ask you, is there any time when the particle goes vertical? Well, if it goes vertical, then I have the denominator of my slope has to equal 0. Well, that happens, we already found at t equals 2. But what happens if I plug in 2? If I plug in 2, I will get 0 over 0. If this happens, you can use L'Hopital's rule. So if I check it, at t equals 0, what is the slope of my curve? It's not 0 over 0. The slope at t equals 0, I use L'Hopital's rule, and I will get 2t over negative 3. So at t equals 2, my slope would be negative 4/3. So be kind of aware of all your other tools if you ever had to do that. So let's say you wanted to find what is the equation of the tangent line at the point 0, at t equals 2. Well, it would be negative 4/3. Then I'd have to find its position at t equals 2. We just got to be basically going through the same kinds of steps we did before. So that's kind of another good kind of an example you can think about.